Hello everyone, my name is Jasul Kumar Thakkar and my design innovation videos topic is Bladeless Fan. So every time we think about a fan, the very first thing which comes to our mind is this bulky rotating machine which is more than likely to be making a lot of noise. So why is there a need for innovation there? Firstly, it's usually very unsafe due to the presence of rotating blades. It's very noisy during operation, it's bulky in structure, which is the reason why it's difficult to clean most of the times. And the air current generated by our conventional fan is usually very choppy and uneven. So, in October 2009, James Dyson, who is a British industrial engineer and also the owner of Dyson Company, introduced this new product in the market which was called Dyson Air Multiplier. And it was a very innovative invention because it used to amplify air up to 15 times and it used to produce a very uninterrupted stream of very smooth air. So, looking at the design description, the fan came in two pieces, which were the outer ring and the cylindrical base. But looking at the overall product, it could be divided into four different main components, which were the outer ring, cylindrical base, mixed flow impeller, and the brushless DC motor. Quickly going through the technical specifications of the fan, the thickness of the fan was 10 inches. The technology used here was air multiplication. There were remote control, also the touch control was available for the fan. There was 10 speed option for the airflow setting. It has 90-degree oscillation movement. It has 10 degrees of lateral tilting, and the overall dimensions for the fan are 19.5 by 12 by 6 inches. So before we jump on to understanding the working of the fan, let's just go through a video by Dyson UK, which will help us understanding it better.
When airflow is forced to change direction, the disrupted air is turbulent. Turbulence is noisy and wastes energy. In the latest generation of Dyson fans, turbulence is minimized, ensuring they're quieter and more efficient than their predecessors. This begins with the intake holes, carefully arranged so air is drawn evenly into the machine. Motor noise is captured and dissipated by a helmholtz cavity, and any vibration is isolated by an acoustically engineered motor casing. The fins of the impeller are asymmetric, so each harmonizes with the others, and they have a scalloped trailing edge to further improve acoustics. An aerodynamic diffuser separates the airflow into controlled parts for efficiency. Air is then channeled equally into the two sides of the loop. It has a larger volume at the bottom, which allows air to enter with less turbulence, reducing noise. As pressure in the loop builds, air is forced out through the aperture at a high constant velocity. As the airflow exits, it clings to the airfoil-shaped ram, generating maximum velocity and projection. Surrounding air is then drawn in from around the loop, amplifying the volume of air projected. This is how air multiplier technology projects smooth, powerful, high-velocity airflow. Powerful airflow, no blades.
So the working of the fan can be divided into four simple steps. The first one being the air suction, which is nothing but the air which is getting sucked from the small vents which are provided in the base at a rate of 32 liters per second. The second step is air acceleration, in which the air is forced up into the loop amplifier or the ring structure using the impeller, and it passes over the 16-degree aerofoil, which not just channelizes the direction of the air but also increases the velocity of the air coming out of the fan. The third step is air inducement, which is nothing but the process in which the air behind of the fan is also drawn into the airflow, and the final speed of the air which is coming out of the fan is 55 miles per hour. The fourth step is air entrainment, which means that the air around of the machine is also drawn into the airflow, and it basically increases the total volume of the air which is coming out of the fan. So why is this design innovative? Now, clearly, according to me, it is one of the most innovative designs I've come across because it has completely changed the conventional perception of how a fan is supposed to be. It doesn't have any accessible moving parts, which makes it a lot more safer. The air current which is produced from this type of fan is very uniform and pleasant, which was very choppy in the conventional fans. It is aesthetically very appealing. The power consumption for such a fan is very less. It is lightweight and it's very easy to clean. There is no noise generation, and the controlling of this fan is also a lot more better than the conventional fans we have. So the methods in the designing process used for coming up with this bladeless fan was basically iterative prototyping method, which is again used for most of the Dyson products. The steps involved in this designing process are: firstly, proposing a radical innovation or a new idea or concept for an existing product. The second step here is creating a prototype to just test that idea or concept. The third step is experimentation or testing for that specific prototype. And the last step is creating many prototypes and making incremental innovations to serve the design needs better and better. Following is a list of references I used to make this video. Thank you so much, and that's all from my side. You guys have a nice day.